Fusion 360 is a cloud-based computer-aided design, manufacture and engineering tool for collaborative product development. Fusion 360 combines fast and easy organic modeling with precise solid modeling to help you create manufacturable designs. When it comes to design, you can choose from integrated methods such as freeform, parametric, sheet metal, direct, surface, or mesh modeling. If your design is more on the artistic side, you can create a form and then manipulate faces, edges, and vertices to get your desired geometry. If your design has finer details, then you can use parametric modeling, which ensures your design has a timeline, so any design changes are captured and updated throughout the model to ensure the correct form and fit. If your design has sheet metal parts, you can use the sheet metal tools to create flat patterns while compensating for bends. To design without any restrictions, you can use the direct modeling method to translate, rotate, and change geometry without breaking a complex feature. This is useful for quick edits, defeaturing, or repairing imported geometry from other CAD tools. To patch up openings in a model or create other complex designs, you can use surface modeling. If you have scanned files that are brought in as an STL or OBJ, you can use the mesh tools to repair or edit the files. Fusion 360 gives you the flexibility to choose your preferred modeling method when it's most convenient in your product development process. Even combine them to create innovative designs. Next, the generative design approach will simultaneously synthesize multiple CAD-ready solutions based on real-world manufacturing constraints and product performance requirements. When you've created your geometry, you can assemble the pieces and ensure the proper motion is captured and restrained. Assembly modeling will describe the working relationships between the components with joints, such as the sliding or rotational joints. With joints, you can limit the range of motion, add cause and effect, and other relationships. Before moving forward with the design, you can simulate it inside of Fusion 360 in the simulation workspace to validate your design. You have the choice between study types like the common linear static analysis, to thermal, modal frequency, buckling, and many more. You can offload the study generation to the cloud, which enables you to generate more studies without using up your own computing power. So you can go through more study types and more iterations to gain valuable insights about your design. Ultimately, you use these insights for better design decisions. At whatever stage of the design process, collaboration is made easy with Fusion Team. Whether you're on a Mac, PC, web browser, or mobile device, use Fusion Team as a single place to discuss, mark up, and collaborate on designs. You can also use Fusion Team to manage your team and projects. Once you've had feedback and finalized your designs, you can create high-quality renders to document your designs. When you're ready to send your designs for manufacture, you can create production drawings. You can lay out views, add dimensions, tolerances, and create a bill of material. To aid any drawings, you can create animations to help describe assembly or disassembly procedures. By the end of this Getting Started in Fusion 360 course, you'll build a strong understanding of how designs are made and assembled. This design forethought will make those inevitable design changes easier when designing for your own applications. Once you're familiar with the design processes, you can continue your learning journey by learning about using the manufacturing capabilities that come within Fusion 360 so you can transform your designs into real products. To program your part for manufacturing, Fusion 360 has toolpaths for 2.5, 3, 3+2, 4, and 5-axis milling. In addition, turning and mill turn, and 2D profiles for water jets, laser, or plasma jobs. To help improve your workflow, you have access to a fully customizable tool library. On your machine, reduce setup time and increase process reliability with automated probing cycles. With an extensive list of finishing strategies, you can tackle any geometry to get your part machined. You can also access tools for additive manufacturing. Here you can generate a toolpath for your additive process and then simulate it so you can have the confidence that your part will come out as you expect. Lastly, you can use the electronics workspace inside Fusion 360 to create electronic designs. Create your schematics and PCB designs and then export your file for manufacture. As you can see, there is so much to unpack. We hope you're excited about your learning journey with us. Thanks for watching.